All right, in this third and last video for graphing sine and cosine with period changes and phase shifts, we're going to look at a couple of examples in which we find there will be both a change in the period and a phase shift. So first we're going to start off with graphing this function g of x equals -2 times the sine of x halves minus pi fourths radians. So structurally, we should recognize that our -2 is our a parameter. And actually, let's rewrite this so that it's a little clearer. So this would be -2 sine of. So here we have to realize this x divided by 2 would mean 1/2 times x, and then minus pi fourths radians. And then we can add a plus 0 there for structure if we want to. So again, the -2 is our a parameter. The coefficient of x, which is that 1/2, that's our 1 over b parameter. The opposite of this negative pi fourths radians is what we call c. And then the 0 is our k value. So when we calculate the period for a sine function, we take 2 pi radians, which is the period of the parent function, and divide it by 1 over b parameter, its positive value, which it already is positive. So we're dividing by 1/2. That would be 2 pi times the reciprocal of 1/2, which is 2. And that gives us a period of 4 pi radians. Then we have an amplitude that is the absolute value of our a parameter, and absolute value of -2 is 2. Now at this point, or at some point, it's probably a good idea to somewhere write down that because your a parameter is negative, you will have to remember to graph an x-axis reflection. All right. Now going back to our midline equation is y equals k, so y equals 0, which is our x-axis, and then phase shift. So phase shift is c, so that's the opposite of this negative pi fourths, so the positive pi fourths, divided by the 1 over b parameter, which is 1/2, and that would be pi fourths times 2, and that would simplify to pi halves. And so our phase shift is positive pi halves, which means that we have a translation to the right pi halves radians. All right, so now we're going to look at drawing our axes, figuring out a scale to use for our x-axis. So possible scale, I can take that period of 4 pi radians, and divide it by 4, and that gives me pi. That seems a little large to me, and especially because my phase shift is smaller than that. It's pi halves. So I could use pi, but a lot of my points would end up on or in between squares. So I could also use a factor of this, which would be pi halves, and that being equivalent to my phase shift, I like that. So I'm going to use a pi halves scale for my x-axis. All right. So we have an amplitude of 2, but our midline is still the x-axis. So we're safe with putting our x-axis in the middle of our graph. Then if we want, our phase shift is to the right, so if we want to graph mostly left to right, we would push our y-axis over here to the left. All right, so I'm using this pi halves scale, so that means that every 2 squares will be a multiple of pi. So this will be pi, 2 pi, 3 pi, and so on. And over here, this would be negative pi. For my y-axis, I'm just going to use a scale of 1 unit. So this would be 1 and 2. -1 and -2. So I could draw a dashed line on top of the x-axis if I wanted to for my midline, but I'm not going to bother with that this time because I can just use the x-axis as that reference. All right, so now I am graphing, or we are graphing, a sine function. And we need to know, and should know, that sine will start at 0, 0. So the only thing that's going to affect this point are the translations. So we have a translation to the right, pi halves radians. We have no translation up or down. So that means that this point shifts to the right, pi halves radians, and ends up right here, if I can get point for me? Almost had it. Okay, we'll be satisfied with that. All right, our period is 4 pi radians, which means 4 pi radians after that point is the end of this first cycle. So again, our 4 pi here is 2, 4, 6, 8 squares. So we could just count 8 squares, or we can take 4 pi and add it to this 1/2 pi and get 4½ pi that way. We should find that our cycle ends here. And we'll notice that's 2, 4, 6, 8 squares. All right, what we also need to remember about sine is that halfway between these two midline points, there'll be a third midline point that separates our relative maximum and minimum. Right there. So now, remember, sine from its first midline point moves to a relative maximum. That point would be halfway between these two midline points. But we have to pay attention to our A parameter this time. So we have an amplitude of 2, but we also have that x-axis reflection, which means that that relative maximum is going to turn into a relative minimum. And then here we would normally have a relative minimum, but because of that reflection, it turns into the relative maximum. So there's the key points for our first cycle, and then we can extend that pattern for the rest of our graph here. So over here on the far left, we have a relative maximum point here to start us off. So we have to show that with our end behavior. And then it's going to curve through. Remember, nice smooth curves, rounded through the maximums and minimums. We come to another relative maximum, so we show it turning around, heading back to the midline. And that finishes that graph. All right, and for the final example, we'll look at this function, which is a cosine function. So here, actually, we've pretty much got everything that we need all shown to us in this function, g of x. So our 4/3 is our a parameter. The 4 is our 1/b parameter. The opposite of this positive pi is going to be what we call c, and our +1 here is going to be our k. All right, so the period for this function, since cosine's period is 2 pi, its parent function, cosine of x, is 2 pi. We take 2 pi and divide it by our 1/b parameter, which is 4, and this reduces to pi halves. So we have a period of pi halves radians this time. Amplitude, absolute value of our a parameter, absolute value of 4/3 will still be 4/3. We do need to understand that that would be the mixed number 1 and 1/3, so we get those points in the correct positions. Midline y equals k would be y equals 1, so we have a bit of a translation up this time. And then our phase shift. So phase shift, again, we need c, which is the, let's make that look more like a c there, instead of an e. So phase shift, c, is the opposite of that positive pi. So that would be a negative pi divided by the 1/b parameter, which is a 4. And so there's no need to simplify that. That is negative pi/4. It's our phase shift. Since it's negative, that means our translation is to the left, that pi/4 radians. All right, so now time to figure out our axes and scales and whatnot. So possible scale. So my possible scale options. I would take this period of pi halves radians and divide it by 4, which means that I'm multiplying the pi halves times the reciprocal of 4, which is 1/4, and that gives me pi 8ths. All right, so pi 8ths is a good scale, and here's why. It works well for our period, and it is a factor of pi 4ths, because 2 times pi 8ths gives me pi 4ths, which is my phase shift. So I like this scale. I'm going to use pi 8ths. All right, so now graphing. I do have a midline that's at y equals 1, and then an amplitude of 1 and 1/3, so that means I'm going to have to get up to 2 and 1/3 for my maximums. But other than that, not a big deal. So actually the x-axis being in the middle of our graph should work fine here also. And I do have a bit of a phase shift to the left, so I want to make sure I have enough room to make that first shift to the left. So I'm and I'm using a pi-8 scale, which means 2 squares would be pi-4ths. So I am going to give myself 3 squares over there just to make it a little bit cleaner and easier to work with. All right. So every 8 squares is going to be a pi. And so I'm looking at 2, 4, 6, 8. There is pi. Half of that, 4 squares, would be pi halves. Half of that would be pi fourths. And this would be 3 pi fourths. And then 2, 4, 6. I don't quite make it to 2 pi, which that's okay, because our period is very small here. So this would be, but every 4 squares is a half, so I know another 4 squares would be 1.5 pi, or 3 pi halves. And so this is my 5 pi fourths, and this is my 7 pi fourths. I think. Yep, another 2 over there would take me to 8 pi fourths, which is 2 pi. So backing this up, this would be negative pi fourths right here. All right, so we are graphing a cosine function. For cosine, we need to understand that it starts at 0, 1. Oh, let's get some numbers on here. So I'm just going to use a scale of 1. I know we've talked about using a 1/3 scale here. Do I have that? I guess I do have enough room. I did put it in a position. This could be 1, 2, and that would be 2 1/3 right there. So that'll work. Okay. We can use that 1/3 scale we've talked about if you prefer. All right. So cosine starts at 0, 1. So what all is going to happen to that? Oh, midline. Let's put our midline in there. So midline is at y = 1. So here is my midline. So going back, all right, cosine starts at 0, 1. What's going to happen to it? Well, it is going to have to be affected by our translation up, our shift left, pi fourths radians, and this new amplitude of 1 1/3. So let's do the amplitude first. So there's no x-axis reflection, so we know it's going to be 1 1/3 units above the midline. That would put it here. That handles both the amplitude and midline change transformations. But it also has to shift left pi fourths units. So that puts it shifting to the left over here. So that point is going to begin the first cycle of this cosine function. Then pi halves units later, and pi halves is 4 squares, notice, we would have another relative maximum right there. Halfway between those two, remember, is a relative minimum. So that would be 1 1/3 units below the midline, and then halfway between each of those is a midline point. And then we can finish everything up. So each of these key points is actually only 1 square away from the other. So we have a point there on the left, and then midline, minimum, midline, maximum, and so on to finish up the key points to the right. Drawing in the curve. So I'm starting at a midline point, so it's heading down to its next relative minimum. And so on. And the ending of a relative or a midline point takes it down towards the next relative minimum to the right. And that finishes this one. All right, so that is the last example we have for graphing sine and cosine with period changes and phase shift. We should be hopefully ready for the assignment.